Now, so next we deal with this idea called composite functions. Now, we learn about functions, functions of number processing rule. What happens if I put this a number through two functions one after another? I give you a simple example. Let's do a simple example. What if I say fx is 2x and gx is x plus 1? Now f is a function such that you multiply 2 to all the numbers. G is a function that you add 1 to all the numbers. If I have a number 10, clearly under f I'll get 20. Then under g I'll get 21. Then I put 20 to the function g, I'll get 21. Now the question we have is, can we have a composite function? That means we jump straight. Can we have a function that processes number 10 all the way to 21? And we call it this composite function g. Now, I think intuitively we all know, if fx is times 2, you times 2 to all the numbers. Gx is plus 1 to all the numbers. If you want to jump from 10 to 21, you just times 2 plus 1. I think we all know. So this idea of composite function is, then can we find a general expression? If this is x, then what is this one? Yes? But before that, let's get the terminology correct. If you put a number through f and then g, this composite function is called gf, not fg. I repeat one more time. You go through f first, then g. This composite function is called gf. Why is it gf? I think let's clear it once and for all. Why? Reason is very simple. You see, first, this thing is called f10. Correct? You put the number 10 under f, you get f10. Then you map it through. This is called G20, right? Which is G of f10. Make sense? Because this is mapped under G. So therefore this is GF10, not FG10. Does it make sense to all of us? Yes? So therefore f followed by g, the composite function is called gf, because look here, this is gf10. This whole section, next section, is then how do we determine the general rule. But before that, let's get some examples out of the way. Another two functions, fx is this, gx is this. A slightly more complicated rule, gf again, I want to emphasize, gf is put under f first, then g. Because you look carefully, gf is g bracket f. So you work, you get numbers. You put it in, you get the number 55. This is gf2. Do we expect fg2 to be the same value? Let's try and work it out. What is G2? G2 is 2 times 2 squared plus 5. Make sense? Yep. Which is F13. And F13 is 3 times, what just happened? 3 times 13 minus 1, and then you get 38. You realize that 38 is different from 55. In general, FG and GF are different. You cannot say that they're the same. All okay? So, now we learn that, then how do we then find the general value? How do we find gfx for a general value of x? I think it's not difficult. gfx is gf here. You put fx under g for general x. All you need to do is to say that this is g, 3x minus 1. That means let's take a look at g. The rule for g is that you square it times 2 plus 5. Square it times 2 plus 5. Simplify, you'll get 18x squared minus 12x. So you put a fx into it, you get fx. You put it under g, you get gfx. And this happens to be this expression. Of course, you can work out the general expression for fgx. You realize that this expression and this expression are not the same. I think it's quite obvious. Now, there is a difference between fg as a composite function versus fx times gx. This is product. This is composite function. It means totally different thing. Or they are not the same. Clearly, they are not the same. Another concept we want to take a look at is f square x, and what is the meaning of f square x and what is the meaning of fx squared. I don't think I want to use a complicated looking example, but I just want to give you a simple example. Say that fx is x plus 2. What do we actually mean by f square x? F square x is actually f followed by f. You think about it, this is a number that you go through f one time and then f another time. Oops. I don't mean, no, nothing, not scolding anything. So you think about it, if I have a 5 here, you add 2, you get 7, add 2, you get 9. 10 here, you add 2, you get 12, you add 2, you get 14. So does it make sense that f square x is actually fx plus 2 is actually x plus 2 plus 2, which is x plus 4. Because you plus 4. You plus 2 one time, and plus 2 another time. You plus 4. But fx whole thing square, it means totally different. Fx whole thing square is x plus 2 whole thing square. Totally different. It cannot be the same. All good? Now just quickly answer this question. Fg inverse, does it mean this or this? Quick answer is that this actually refers to Fg inverse. Do you need to, if you mean this, you actually don't need the bracket. This is good. Why? It doesn't mean the whole thing inverse. In algebra, when we write x, y squared, what does it refer to? We actually mean x, y squared, not x, y whole thing squared. Am I right? So why should we do something different for functions? Agree? Yes? So by definition, this one, the moment you see this, it means this one, not this. Okay. Alright, example 5, last example before we end this chapter. Given that fx is 3x plus b, gx is 3a minus 2x, and fgx is gfx plus 2 for all real values of x. This is the one that we're going to use to solve the problem. So let's take a look at the left hand side. This is left hand side. This is left hand side. This is the right hand side. So left hand side we simplify. You get a general expression for fg. You get this. Okay. What about the right hand side? Can we simplify? I think it's not difficult to simplify. You get g of fx plus 2. What is fx plus 2? We know what is fx. Just replace x with x plus 2. You get 3 x plus 2 plus 2. You get g 3x plus 6 plus 2. Then you get, sorry, just hang on a while. The simplification. Then what is actually G of this whole thing? G of this whole thing is you to replace X with this whole thing. You get 3A minus 2 of this whole thing. Make sense? Yeah. So you get a 3x 6, which is 3a minus 6x minus 12 minus 2. So now since you are given that left hand side and right hand side are the same, you just plonk it in. You get 9a minus 6x plus b equals to 3a minus 6x minus 12 minus 2. All you need to do is do this 6x and 6x goes. Alright, then make 6a, because the 3a and the 9a become 6a. Yeah, equals to, then you bring the minus plus b, minus 2b, you bring across, you get a minus 12 minus 3b. Therefore, a is equals to minus 2 minus half b. The end. The end. End. Why is it not ending? The end.